Okay, welcome everybody to this section titled New Cross-Cutting Perspective for Industry 4.0. I'm Antonio Forcina, one of the co-chairs of the sections, and with me is online Luca Silvestri, another co-chair of this section. Unfortunately, Nuno Suarez, the speaker of the first scientific contribution, is not able to join us because of some connection problems. So we will move his presentation at the end of this section, hoping he will be able to join us. We have other three scientific contributions. The first one, after moving Nuno's presentation at the end, is titled CFD Modeling in Industry 4.0, New Perspective for Smart Factories, and the speaker will be Luca Silvestri. The second one is titled The Lean Production and Industry 4.0 Strategy Management or Technical Implementation, a Systematic Literature Review. And the speaker will be Chiara Cagnetti. And I will present the last contribution titled The Role of Industry 4.0 Enabling Technologies for Safety Management, a Systematic Literature Review. So, please, Luca, start with your presentation.
Okay, can you see my screen?
Yes.
Okay. This is Luca Silvestri. Thank you, Antonio, for your introduction. I am a research fellow from University of Rome, Nicolò Cusano, and this is the presentation of my study, CFD Modeling in Industry 4.0, New Perspectives for Smart Factories. I will start with the motivations, goals, and scope. I will introduce the computational fluid dynamic simulation and the general CFD workflow. I will present the literature review results for CFD simulation in smart factories and the discussion of the key elements for a CFD implementation. Then the conclusions. In the modern manufacturing, the industrial market competition have to face different market fluctuation, time to market, and product customization, and to the companies are demanded to address such issues through flexibility and reconfigurability. Industry 4.0 technologies already provide benefits to companies in terms of higher flexibilities, responsiveness, and cost savings. Here in this slide, we have the 9 technologies characteristic of the Industry 4.0, the so-called 9 pillars of technologies that are the cyber systems, big data and analytics, horizontal and vertical system integration, the simulation that include the CFD simulation, cloud computing, augmented reality, autonomous robots, additive manufacturing, and cybersecurity. This is the goals of my work that were to understand if and how CFD simulation can provide benefits to industry. The second goal is to develop a comprehensive framework for understanding key elements for the CFD implementation in an Industry 4.0 context and related advantages. The scope of my work was a literature review of the technological state of art and the integration and how to integrate CFD simulation technology with other Industry 4.0 technologies. I would like to introduce you the computational fluid dynamics CFD through 3 questions. The first question is, what is a CFD simulation? CFD is defined as the analysis of a system involving fluid flow, heat transfer, mass transport, chemical reactions through the computer-based simulation. The second question is why CFD simulation? CFD is able to integrate both experimental and theoretical work and allowing a cost reduction, the theoretical simulation of any physical condition and geometry, and the possibility to extract data in each location of the domain. The third question, that is the most important for my study, is where CFD simulation. CFD has a critical role in many engineering applications, for example in heating, ventilation and air conditioning, combustion and the interaction between fluid and objects. This is the general CFD simulation workflow. It's composed by three main parts. That the first part is the pre-processing, in which the geometry is modeled. After this, we have to generate the numerical grid that is named mesh, and we have to define the physical model. The second step is the solving, that consists in solving the transport equation like mass, energy, momentum, and the physical models such as combustion and radiations. After this, we have to set up materials, boundary conditions, and other solver settings. The last part is the post-processing, that consists in the visualization and interpretation of graphical and numerical results, for example, contour plots or tabular data. This is my research methodology. I investigated the main scientific databases such as Scopus, Google Scholar, IEEE Explore, and the Web of Science through several keywords like CFD, Industry 4.0, Smart Factory, and their combinations. The second step was the selection process, in which I first read the title of the paper and then the abstract, and if they fell into the scope of my work, I continued reading the whole article and decided if include or not it in my database. The last step is the assessment and reporting of findings. As a first result of my literature review, I found that the CFD simulation in a smart factory can be divided in two main families, that is the air ventilation and the air conditioning. The air ventilation includes the high velocity and temperature, the particle distribution, pollutants concentration, and gas dispersion. The air conditioning instead includes the thermal comfort for operators and occupants, but also the optimal thermal condition for machine health and products. This is a content summary in which I extracted part of my database just for highlight the main applications that several authors already applied in a smart factory. As a first, we can consider CFD simulation a useful tool for predicting particle distribution in a clean room, for example, for hard disk drive production, but also for designing an optimal machine layout. It's possible to use CFD simulation for knowing the ventilation performance and particle distribution in complex layouts. CFD can also be used for studying the quality of inhaled air for operators through the temperature distribution field, for example, or for predicting gas explosion in a control room for oil and gas industry. It's possible also to model heavy gas dispersion, and several authors agree that CFD is a promising tool for ventilation design in two specific sectors that are the food and the pharmaceutical one. Here I collected the main advantages that I found for the implementation of CFD in a smart factory. As a first, it is possible to obtain an annual energy saving, optimizing fan speed and fluid temperature, and but also energy intensive assembly processes. Furthermore, downtime and scrap can be reduced, avoiding production shutdowns, for example, from overheating. It's also possible to protect in the same manner sensitive machinery. Also retrofit, it's possible to maximize, for example, through the optimization of the design of a ventilation and air conditioning system. Finally, it's possible to optimize also the design of pollution extraction systems. All these advantages directly reflect in maintenance, both tasks and strategies, but also they allow to increase the production capacity and to obtain a quick change of layout. This is the final framework that I realized during my literature review process, and I figured out how CFD simulation technology can integrate with others Industry 4.0 technologies. The first one is the big data and cyber systems, thanks to the operating data that we can obtain directly from sensors, and the other machine operating parameters and data analysis, of course. Another technology is the cloud computing for not only for sharing, but also for CPU and GPU sharing that can allow to reduce the simulation time. The last technology is the augmented reality that allow to superimpose CFD visualizations directly in smart device like tablet or wearable, like a smartphone, a simple smartphone. For example, a maintenance operator can use his smartphone directly to see the temperature field during maintenance tasks. In conclusion, I can say that the Industry 4.0 simulation technology has already a fundamental role in today's industrial market. In particular, CFD simulations allow several advantages in smart factoring, predicting smoke and fire risk in buildings, but also for quantify indoor environmental quality and to design proper operating conditions for operators and systems. CFD simulation represents a key element for a fast layout reconfiguration, for realizing a flexible product customization and manufacturing processes optimization. The sector that can have the most of the advantages are the food and the pharmaceutical one, because to these sectors is demanded a constant changes in layout for hygiene, health and safety legislation. As a future outlook, I will consider to develop a case study for the CFD implementation in a smart factory. Thank you for your attention. Okay.
Thank you, Luca, for this really interesting presentation and also the interesting topic. I ask if is there any questions from the auditors.
I actually have a question, which is not really a question, but just an insight of this very interesting work, because we are living in the COVID pandemic era, and I think that CFD would be very interesting also to understand air ventilation flows, even inside the factory, for to support proper health conditions in the factory. So are you already planning to work on this in the next future as a potential future scenario, or not?
Of course, this is an interesting topic, and all of us we should address now how to improve the quality of life also in the work environment, no? And I know that already not several but few studies were already made about to implement CFD simulation for simulate the flow in room, like also restaurants, for example, where there is people, then occupants, and then allow to know in advance the air flows, and they obtain very relevant results. For sure, this is a promising technology promising technology in the factory that for sure will be used in the future. This is my opinion.
Yeah, definitely. It has maybe already been used in some restaurant scenarios, but maybe in industrial domain is not yet very popular. I mean, thank you for your answer.
You're welcome.
So I also have another question for Luca. And in particular, I would like to know something more about cloud computing and how and why do you think this technology could be so important for CFD?
Yes, thank you for the question. Cloud computing is not, of course, only the storage of data that, for example, for CFD simulation, a large amount of data we have to storage that are the results of CFD simulations. But furthermore, one of the most important skill that is inside the cloud computing, that is a very big technology, is the CPU and GPU sharing. In fact, some company like Amazon already allow the computing power on demand. No, so we can share. Only, for example, for a simulation, we can rent a part of the computing power of Amazon during the time that we have to spend for our simulation. So a factory that doesn't have this, has not these possibilities, no, in computing resources, can share occasionally just for their study.
Okay, thank you for your answer. Is there any other question? I think we can move to the second scientific contribution, and please, Chiara Cagnetti, to share her presentation. We can't hear you, Chiara. No. No audio.
Can you try going with the three dots next to the hand? More actions, hide device services, settings, device settings, and then you should be able to select the correct microphone.
We can't hear you anymore. Joe, so just give Chiara some seconds to set her microphone in the right way. Chiara?
Just a moment, Chiara Cagnetti has got a problem with the mic.
Okay.
If you want to continue the program, you can go if you want.
We can move her presentation.
Yeah, the next presentation. Yeah.
Okay, thank you.
Okay.
So
Then the next presenter. The next presenter is Antonio Forcina, and his study is the role of Industry 4.0 enabling technologies for safety management, a systematic literature review.
Oh, grazie. Praticamente mo devo rispegnere perché praticamente questa si aggiorna.
Chiara, you should close your mic.
Oh yeah.
Okay. You should close your microphone, and now we jump to the other presentation with Antonio Forcina. After him, you will present. Okay.
Okay, thank you.
okay, can you see the presentation? I have to start. Okay. Can you see the presentation?
Yeah, yes, we can see the presentation. Thank you.
So, this research was carried out to evaluate the usefulness and the impact of Industry 4.0 technologies in safety management of different production contexts. For this purpose, we will first make an overview of the research context, then illustrating the methodology used, the analysis of the result, and finally conclusions and future developments will be drawn. To date, over 3,000 scientific publications contain the term Industry 4.0 in their title. This shows how great is the attention of researchers on this topic. And to this great attention also correspond very large economic resources made available by countries or national and international government entities. Industry 4.0, as is known, is innovating manufacturing by applying and integrating the so-called 9 pillars or technologies in order to, I would say, to allow the transformation of a conventional factory into a smart factory. The application of these technologies can take place in different areas of industrial systems. Some of them are directly linked to the product or the production process. Other, I would say, are collateral in some way, but equally important, such as, for example, sustainability or safety. And in this context, we choose a systematic literature review as research tool. This tool is, in fact, widely considered as a powerful tool to investigate the current knowledge in relation to a specific research question, since it is carried out through a replicable replicable process, eliminating the risk of bias or non-critical evaluation. In particular, with our review, we tried to answer two questions, which are: which is the interest of the scientific community in the application of Industry 4.0 technology for safety management, and which technologies have the greatest impact on safety management. So the step of our review. For our systematic review, the results were acquired from Scopus, and after the identification of the research questions, the steps forward were the choice of keywords, the identification of search criteria for the selection of documents, and the extraction of results from database and their discussion during a synthesis phase. In particular, 9 searches were carried out using each Industry 4.0 technology and safety management as keywords. The search fields were abstract, title, and keywords, resulting 299 documents. As you can see, among these documents, about 77% refer to 3 particular research areas, which are engineering, computer science, and management and accounting. On the basis of the identified selection criteria, the results were refined by concentrating on articles or reviews written in English and related to the above 3 research areas. Finally, we removed duplicates, of course. The results show how the most used technologies for safety management are Internet of Things and cloud, often used together. Why these technologies are the most often used? Because these technologies are well suited to the transmission of data in real time and to their storage and management, allowing to create a very functional network for safety management. The temporal distribution of the articles shows an increasing trend, in particular, of course, from 2015, and it should consider, of course, that the results of the current year are not complete since it were extracted in June 2020. As for the geographical distribution, based on the country of origin of the first author, China is the country with the largest number of articles, 31 articles, which correspond to 45.6%, followed by United States with 16 articles. Moreover, we analyzed in detail the documents, and we tried, it is possible to divide them into 2 clusters. The first one we defined empirical, contains case studies and interviews. The second one includes articles, and we called conceptual, concerning models and reviews. As you can see, 41 articles out of 68 concern case studies demonstrating how in this area research is mainly applicative. Among the analyzed documents, some interesting applications were chosen in order to show some remarkable results. The first one is a smart helmet, so-called, for real-time tracking and location. This prototype has been developed using IoT and cloud architecture, which includes infrared detector and thermal infrared sensor, RFID trigger for location, smartphone application for personalized alerts, web application for data visualization and alarms, and cloud server for data storage and retrieval. Another interesting application is a software called PSIM, Physical Security Information Management, able to integrate the physical safety system into a single user-oriented interface based on GPS and cloud computing. The last application we have chosen is a model based on wireless sensor network, one of the key technologies of IoT, and based also on the building information modeling. This model allows to view the entire construction lifecycle management. In conclusion, to answer the questions of the systematic review, we can say that the application of Industry 4.0 technology for safety management is a highly topical issue for researchers, providing new incentives and research in this area. We can also say, of course, that IoT and cloud are the technologies with greatest impact on safety management. What about future developments? The future developments of this research consist in a stratification of technologies depending on each industrial sector, and moreover, in a development of a method to evaluate the impacts of the technologies in terms of safety improvements and costs. Thank you for your attention.
Thank you, Antonio. A very interesting topic and an effective presentation. If there are some questions by the audience, I don't see any hands rose, so I have a question for you. Yeah, very interesting, but how, it's maybe your opinion, but how do you think that the trends that you highlighted will evolve in the next year?
Okay, so I expect an increasing use of Industry 4.0 technology, and I believe in particular that some applicative technologies such as additive manufacturing or the use of robots, autonomous robots, can have impacts in terms of improving working conditions, you know. Okay. And if we improve working conditions, we can for sure have benefits in terms of safety management.
Okay, thank you, Antonio. Additional questions from the auditors? Okay. If nothing, we can continue with Chiara Cagnetti.
Good morning.
Good morning.
Good morning. Okay, you should share your screen.
Ok. Come non funziona?
Do you have problems?
Chiara? Chiara, do you have
A problem, yes. My
yes,
PC.
you should press the button Open Share Tray, and after this, you will see in the bottom several windows. Okay, you should select the window of PowerPoint.
But my PC don't present the presentation. Have a problem.
Okay.
Okay.
Send your presentation
yes.
by email to Luca.
Okay.
And he will share the PowerPoint and you will talk on this.
Okay.
Okay.
One moment.
And also a copy in PDF.
Okay.
Okay. Okay, so we can continue with Nuno Suarez. I don't know if no, I cannot see him.
So I think,
unfortunately, Luca was in touch with Nuno and is not able to join. So he apologizes for the inconvenience, but he is having issues with the connection.
okay.
Okay, so we wait for the wait for Chiara email.
One moment.
Yes, okay, Chiara, you remain in touch with us. You are not able to share also the PDF, is right?
Okay. Yes.
No, okay, but are you able to share the PDF instead of the PowerPoint?
Yes.
Okay, so we can try directly from your computer.
Okay.
To share the PDF. Okay, and you can try to present directly from the PDF instead of the PowerPoint. Okay.
My Mac.
So I suggest you to try again to press the button Open Share Tray.
The Mac don't.
Okay.
No.
Maybe the problem is the Mac.
Okay.
Okay, but if you simultaneously open the PDF, okay, open the PDF with your presentation.
Okay.
Try to press this time the button Open Share Tray, and tell me what you see in the below part of your screen. What appear?
No.
Nothing. But yes, but what appear?
Nothing.
Nothing. So it's not implemented on your Mac. Okay. Now
It's have a problem.
Okay. Plan B. Send me your presentation, and you will suggest me when to go ahead, and I will move your presentation and you will comment. Okay.
Okay. Okay. I send you the presentation.
Okay. Did you already send me the presentation?
Yes.
Okay, in the Gmail?
Yes. I think.
I didn't. Okay, now I have. Presentation convenient. Okay, we can use. Why not the PowerPoint one? Okay, so now I will share my screen.
Okay.
And you will present. You can tell me next directly, and I will press the button. Okay.
Okay.
Okay, Antonio, can you see the presentation?
Yes.
Yeah, sure, we can.
Okay.
Okay.
Please.
Okay. Thank you. This paper is called Lean Production and Industry 4.0, Strategy Management or Technical Implementation, a Systematic Literature Review. This paper is realized from 4 authors, and these authors are Chiara Cagnetti, Tommaso Gallo, Cecilia Silvestri, and Alessandro Ruggeri. They belong to Department of Economy, Engineering, Society and Management from University of Tuscia. Next slide, please. Okay, thank you. In the summary, briefly, we are shown the concept of the presentation. Industry 4.0 and Lean Production concept and relationship, systematic literature review, formulation of research question, collecting of materials, descriptive analysis, selecting of categories, material evaluation, discussion and conclusion. Next, please. Industry 4.0 and Lean Production concept. The concept of Industry 4.0 was born in 2011 at the Hannover Fair in Germany, but still today we haven't a definition of this concept. We can affirm that the Industry 4.0 offers to the company faster and more flexible process by digital tools. The means of Industry 4.0 are workplace empowerment, reduced delivery time, best quality of product, and sustainability. The strategy of Industry 4.0 are ICT and digitalization, cyber physics system, network communication integration with the Internet of Things, simulation, big data, and cloud computing. The Lean Production is a management technique that produces efficient process in other sectors of activity. The means of Lean Production are to get rid of waste in the production process, to improve and increase the flow of activity, and increasing value of quality and quality of product. In the last year, are increasing the study regarding the relationship between Industry 4.0 and Lean Production. To apply efficient the Lean Production in the company is necessary the use of ETC technology. These tools and techniques increasing the value of consumers. They use a standardization process and increasing productivity and flexibility. Next, please. To analyze the relationship between Lean Production and Industry 4.0, we realized a systematic literature review. Systematic literature review is based on identification and assessment of particular research issue or study events. The systematic literature review is composed from 5 steps, which will describe from slide following. The 5 steps of systematic literature review are formulating of research questions, collecting of materials, descriptive analysis, selecting of categories, and material evaluation. Next, please. The first step is called the formulation of a research question and identify the research question. In this paper, the research question examines the identification of 2 different study clusters. The first study cluster is called the strategy management and considers Industry 4.0 and Lean Production as managerial strategy. The second cluster is called the technical implementation and expects the implementation of Industry 4.0 and Lean Production in the companies. Next, please. The next step is called collecting of materials and identifies the step to collect the papers with online database. We are used to different database, Scopus and Web of Science. To identify the papers, we followed 2 different processes. In Scopus, there were 2 steps. Step 1, identify the keywords. Step 2, search the paper with the criterion and identified 52 papers, and in step 3 we filtered the words and identified 16 papers. In Web of Science there were 2 steps. In step 1 the papers researched with the keywords and identified 47 papers. In step 2 the papers searched with filter words and we identified 15 papers. After we compared the papers found and identified 6 duplicated. In total, we have identified 45 papers. The research was made on March 27, 2020, and have been identified 25 papers that we can use or realize a systematic literature review. Next, please. The third step is called the descriptive analysis and identified the descriptive analysis of the paper. The study about the relationship between lean production and Industry 4.0 is increasing the last year with a major number of publications in 2019. The International Journal of Production Research is the journal with the greatest number of publications, in total 7 in the year. Next, please. The next step is called the selecting of categories and identify the dimension and the categories of the literature analysis. The categories and the dimension identify can be inductive or deductive. The dimension identified are methodological research, cluster of research, sector of industry, and the country of the first author. The categories of methodological research are review, survey, case study, focus group. The categories of cluster of research are strategy or technical. The categories of sector of industry are manufacture, multiple back industry. And the categories of the country of first author are Brazil, China, Croatia, India, Italy, Japan, Namibia, Norway, Turkey. Next, please. The last step is called material evaluation and expect the evaluation of the categories. The study has identified 2 different study clusters, and the companies have applied the concept of Industry 4.0 and lean production as managerial strategy. The geographic origin considers the country of the first author. The country of the first author with a greater number of publications is Brazil, follow up Italy. Next, please. The results of analysis show that the year of major publication is 2019. The methodological research is a case study. The research cluster is strategy management. The principal industrial sector is manufacture. The country of the first author is Brazil. The origin of paper is Europe. And the most important journal is the International Journal of Product Research. Next, please. In conclusion, we can affirm that in the last year are increasing the study regarding the relationship between lean production and Industry 4.0. It's necessary to make other study about the concept of lean production and Industry 4.0. For the next research, it's necessary to increase the research with a great number of keywords, and the paper published after on March 27, 2020. The research should be repeated, increasing the new paper and the new information. Next, please. Thank you for the attention.
Okay. Thank you, Chiara.
Thank you. So I'm sorry for the problem.
Okay, don't worry, we solved it in an effective way. If there are some questions by audience, okay, I have a question. It's about this new environment of relative new environment of Industry 4.0. Can you highlight your opinion about the real advantages of lean production in such environment of Industry 4.0?
In the last year, are increasing the study regarding the relationship between Industry 4.0 and lean production. The tools of Industry 4.0 is very important because are applied in more activity. The application of Industry 4.0 tools in lean production will be able to remove limits in lean production, how volatility of demands and poor personalization of product. With the application of Industry 4.0 in lean production can be differentiate the companies on the market, and will be competitive. The application of these technologies on the productive process will create a value throughout the relationship between the man and the technology in the companies.
Okay. Thank you. I have no other question. Okay.
Thank you. I'm sorry.
No, okay.
So, since unfortunately Nuno Suarez wasn't be able to join us because of his technical problems, we are at the end of this section. I want to thank the speakers for the interesting presentations, and I will just say that the large number of literature reviews we have here in this section is synonymous that the research is still in a first phase, and researchers have a lot to do about the applications of Industry 4.0. So thank you, everybody.
Thank you, Antonio.
Thank you very much.
Bye.
Goodbye.
Bye, thanks.
Goodbye, thank you.